Hello, today we will talk about how to calculate the pH of a weak acid or a weak base solution. To begin with, we need to introduce concepts such as pK and pC. They are analogous to pH. That is, pK is the negative decimal logarithm of the dissociation constant, and pC is the negative decimal logarithm of the concentration. For example, we can calculate the pK of acetic acid, which is the negative decimal logarithm of its dissociation constant. This constant is equal to 1.82 times 10 in minus fifth. The negative logarithm of this number is 4.74, which is the pK of acetic acid. Strong acids and bases dissociate almost completely. For instance, if we take hydrochloric acid, the concentration of H plus ions in an aqueous solution will essentially be equal to the initial concentration of hydrochloric acid. However, if we take acetic acid, the concentration of H plus ions will not be equal to the concentration of the acid. It will be significantly lower. Let's write the dissociation equation for acetic acid. It dissociates into an acetate ion and an H plus ion. Next, we write the expression for its dissociation constant. Since the concentration of H plus ions is equal to the concentration of acetate ions, the equation for the dissociation constant can be rewritten as follows. The numerator simply becomes the concentration of H plus ions multiplied by itself. Next, we express H plus in seconds in terms of the dissociation constant and the concentration of acetic acid. Now note that the equilibrium concentration of acetic acid in the K expression is actually the difference between the initial concentration and the concentration of H plus ions. However, for weak acids, the H plus ion concentration is usually much smaller than the total concentration of the acid. Therefore, we can neglect the H plus concentration value and assume that the equilibrium concentration of acetic acid is approximately equal to its initial concentration. Returning to our equation, we substitute the initial concentration and find that the H plus ion concentration is equal to the square root of the product of the acid's concentration and its dissociation constant. As we know, taking the square root is the same as raising to the power of 1/2. Therefore, we rewrite the equation in this manner and take the logarithm of both sides. This means that pH will be equal to the negative logarithm of this product raised to the power of 1/2. As we know from mathematics, when taking the logarithm of an expression raised to a power, the exponent can be moved to the front of the logarithm. Thus, we rewrite the expressions as you see here. Furthermore, we know that the logarithm of a product is the sum of the logarithms of its factors. So we rewrite the expression once more. Since there is a minus sign and a coefficient of 1/2 in the front of the expression, we can expand the brackets and rewrite it this way. Because pK is the negative logarithm of the dissociation constant and pC is the negative logarithm of the concentration, in this case of acetic acid, we can simplify our formula again. Thus, pH equals 1/2 pC plus 1/2 pK. This is the formula of calculating the pH of a weak acid solution. Now let's move to weak bases. By analogy, we can state that PaOH, the negative logarithm of the OH ion concentration, equals 1/2 Pc plus 1/2 pK. To find the pH of a weak base solution, we use the relationship pH equals 14 minus pOH. By substituting our expression for pOH, 1/2 Pc plus 1/2 pK, and expanding the brackets, we arrive at the final expression for calculating the pH of weak base solutions. That's all for today. See you in the next videos.